Okay, so I'm just going to check here to see how we're doing people-wise. Okay. Okay, so for the students that are here, did you guys participate yesterday evening also?
We had about 20-ish students attending us yesterday.
Right. Yep. So, or I'm gonna, and everybody's muted and hiding. So I will pick on Megan Hurley because you show up on my list where I can read it. Just want to check, make sure you can hear and see us right now.
Yep, I can hear and see you.
Okay, great. Okay, so great. There. And now the chat's caught up. it had to wait, and then all of a sudden, oh, then it showed up on mine. Okay. Well, thank you guys for coming. And I just want to welcome you to what we would usually be doing in person. The Big Ten Expo for grad school has been something that Purdue's been running for many years. And we think this is an opportunity for you to get to see and hear a little bit about our institution and in particular, our department, or at Purdue, as we say, our school. So the schools of engineering are part of the College of Engineering. The schools all offer, we have 13 different degree programs. It's a large engineering program. At the end of the day, Purdue's a big engineering school. And because of that, we think that the materials department has a role, and an important part is to be a place where we do high quality research, but we also do things at scale. So, we have a large program, but yet the School of Materials Engineering prides itself historically on being a place that's very family oriented. We feel, if I ask our alumni when they're graduating, what do they take away? They remind me that they felt like they were a family. They felt like they had friends they could work with. They had colleagues that they collaborated with. There were people they trusted, and that the overall experience was something where they got to spend their time working on cool research and building professional relationships that continue into the future. To let you know, this isn't just us saying stuff. As an example, this current year, I think we have 6 or 7 projects that are supporting grad students or undergraduate research that are supported by alumni who graduated somewhere between 10 and 20 years ago. So it's a department that you get to know the people, you get to know the faculty. It's not all about just staying in your group. So we want you to interact with people in all sorts of different kinds of materials. And I will use my Blues Brothers reference here. We have both kinds, country and Western. We work on all kinds of materials. So if you're interested in polymers, if you're interested in metals, if you're interested in ceramics, electronic materials, biomaterials, natural materials that are having reduced environmental footprint, if you're interested in processing materials, growing thin films, or casting steel ingots, we have a place for you. So we have enough faculty and enough students that it's hard for us to imagine there's an area of materials research that there's not somebody here that's already playing in, except for the fact that there's an area that we haven't thought of, and 2 or 3 years from now, we'll be in the mix and be playing in that area too. So it's a big enough program that we have the breadth you need and the tools you need to be able to find and succeed. Like, oh, I need to do this technique. Yep, there's somebody here on campus that does that technique. But it's also small enough that, with about 5 grad students for every 1 faculty member, it's a small enough place that you get to know everybody and you build those connections. And those connections outside of your group are where, if you really see magic happen, that's where the Reese's peanut butter cups of the world work out. So when your chocolate goes in my peanut butter and my peanut butter goes in your chocolate, you end up with something that's better than either one of them by themselves. And so hopefully what you'll see as you go through and as Jihong kind of walks you through the program, you'll see that we have really emphasized the ability to get to explore, let you become you, and let you figure out what the right path is. And the other thing that you're going to see throughout this is that when our students graduate, our graduate students in particular, everyone is a unique story. We do not have a typical. I can't say that the average, well, we have an average, right? By definition, you can mean stuff and say, oh, there's an average. But every person that walks out of here walks out as a unique story. And so whether it's a student that wants to do new titanium alloy developments and goes to work for ATI to work on titanium alloy discovery, or whether it's somebody who wants to work on sensors for biological and agricultural applications and is hired to run Bayer's new North American Research Center here on campus. That happened last year. Or if it's somebody who wants to go work for a really big multinational corporation, something like Rolls-Royce, and work on engines and have to interact between here and England all the time, whether it's people who want to go into academia and teach at a primarily undergraduate institution. Recent grad a couple of years ago was teaching at Western Colorado, which is humorous because he hates snow and he's now 20 minutes away from Crested Butte. Or whether it's somebody who wants to be teaching at a R1 research institution and is bringing in lots of their own grad students and carrying out their own research, whether it's somebody who wants to go work at a national lab, you have all of these as different options. And so our trick is going to be, and what we think makes us special in this, is our ability to help you get to do what you want to do and be successful. So do you guys have any questions for me? Or maybe the better thing to do here is if we don't have any pop up in the next minute or so, I'm going to go ahead and turn it over to Professor Zhang, and he'll kind of walk through some slides. I'll still hang out, and then maybe as questions come up, I can help answer, and he and I can answer any questions you have.
Any question for Dave? All right, so I think you will have more questions if I present some details. The first thing is welcome, all of you to this virtual meeting. We normally do this in person, and this is the first time ever, unique experience, a lot of learning curve for all of us. But we had a good turnout last night, meeting some of the students. I think Megan was there last night, and all the others are probably new. So my name is Xinghang Zhang from School of Materials Engineering, and you just heard the opening welcome remarks by our department head, Dave Barr. He's our nanomechanics expert, research-wise, and I'm going to show you this. This is our itinerary for today. So we have this schedule filled up from 10 all the way to 6. If you need details, you can send me an email or send a Kathy an email. So this is our contact information. So you can contact Rosemary. You can contact, Kathy. She's here taking some notes. So you can send your email contact information by chat. So we appreciate it. So that way we know you are here, so we can follow up with you. So this is for today. So we're gonna have this roughly 30-minute presentation with about 15 minutes for discussion, answer your question. And then we have, material science have our own Zoom rooms. You use a different Zoom link. I will be there all day, pretty much. So we have several Zoom breakdown Zoom rooms where at least one faculty, one grad student will be there, and of course Rosemary and Cassie, they will be there to answer a lot of general questions. But faculty are there and to answer some general questions you may have. And if you feel free to, if you want to talk to students, feel free to do so. Many of these students have been here for some time, 1 year, 2 years, so they know a lot about details what's good about here. Hopefully that's what they're going to say about us. So, all right, and then we'll conclude at about 6 o'clock. And if you have a follow-up question, feel free to shoot us email or directly contact faculty. You're welcome to do so. So let me go through this. I think Megan has seen this, but most others haven't seen this yet. So this is a very quick departmental update or briefing. So basically, let me minimize this. See if I can do that. Okay, there we go. All right, so this is our Purdue mascot, famous Pete, the guy who was using a hammer to make the Biomaker. All right, so historically, our department has really strong metals and ceramics program because we're in the hub of the Midwest manufacturing hubs. So we have a lot of material manufacturing programs and manufacturing capability. And in the past 10 years, we evolved quickly, expanded into many different areas, including polymers, all kinds of composites, electronic materials, semiconductors, devices, additive manufacturing, artificial intelligence, or machine learning. So the general things we all say, you cannot make something without the materials, and that's what we do. We design new materials and try to understand the materials and push the materials to higher performance condition or extreme environments, if you say. This is slightly out of date. I need to update it. Basically, we're top 10 undergrad-wise, the largest undergrad program in the country. We're top 10 in PhD production. As of last year, we had 172, and I think this year we have more students. So primarily PhDs. If you look at this green triangle, this is the PhDs, number of PhDs we have, and we still have master program, but we have this new professional master program. So for a student who wants to do professional master, just to take courses and some research experience. So that's another option. And we also have master's thesis option as well. Feel free to contact us and let us know what is your preference. We are really diversified department. Dave mentioned this, everybody is unique, but we also encourage diversity. So we have roughly about a third female student, 7 to 8% underrepresented minority students, half domestic, half international. And we trying to make department as inclusive as possible. And we not only say that, but we're trying our best to achieve this goal. And we also have a lot of partners from industry. They recruit our students, and we also recruit their employees to grad school here. So it's a win-win situation. This is the history of the department in the past 20 years. 20 years ago, we have about 10 faculty, and nationwide, we rank about 25 to 30. And 10 years ago, we have about 20 faculty. Ranking-wise, we're around 20, 25. And in the past couple of years, we expanded dramatically to about 36, 37 faculty. Right? So David, is it 36 or 37?
Whoops. Right now we have 36.
36, okay.
Yeah,
right.
And that's the people. And if we do have some joint appointments, and then with Arun starting in December, that'll bump us back up to 37.
37, okay, I see. So we are pretty large material science department in the country, and because most other material department has less than 20 faculty, so we're pretty big. And ranking wise, we're consistently in top 15 nationwide. So this is the department research expenditure. And again, I believe Dave has the best number. On the average, 1.4, 1.5 million. Medium is about 700K faculty-wise, and 50 million in the past 3 years. Department research expenditure. So this is something mostly the mixture of federal government research projects and industrial sponsored projects. Application deadlines. I highly encourage you to prepare early and please apply before December 15th. So you might get some surprises. In case you cannot meet the deadline, please send us an email send Rosemary or Kathy an email, let us know ahead of the time. And then we also, so majority of our students apply for the fall semester. So that's December 15th deadline. Some of them actually shooting for spring semesters, like spring 2021. We also accept students. And that deadline is coming up pretty soon. And then this is when we have, commission of regular season. Before COVID-19, we do this graduate invitational, typically in early to mid-February, and we make offers as early as January and as late as like March, April time window. Feel free to contact us or faculty if you have questions about research, research interest, and etc. And then this is a little bit on the matching process for the department. So when you get an offer letter, we do not specify who you're going to be working with. Rather, we invite you over in August. If this is all the students who have accepted our offers, so they come in August and they will listen to faculty presentations. So then they talk to faculty. So that gives you a lot of opportunity to get to know multiple faculty, their research directions, and then you pick the ones you love the best. And then we try to make sure the faculty and student match their best interest, mutual interest. And some details, when you have more questions, I will answer that in more details, but we have this is one of the traditions. So we give students tremendous leverage freedoms to find their best projects here. So we do have a variety of school-wise, College of Engineering-wise, fellowship, Purdue doctoral, very prestigious, Andrews and Ross, and cover, this is university-wide fellowship. So we may look at the students, applications, and we're going to look at, which students are likely to get, we're going to nominate for this kind of fellowships. So now research area-wise, like Department Head Dave mentioned, we have basically covered very broad areas of materials in terms of metal processing. So these are the faculty working in this subject, high temperature ceramics, soft materials, and biological materials, polymers. We have a big group of polymer faculty, modeling simulation, and I should have added Arun Kumar here. He's a new faculty, electronic materials, and you will see some of their face in a little bit. Now, I'm going to show some very brief snapshots about some of these faculty. This is Leah Stanchu. She's our soft materials expert, and they do a very cool devices, and their research is frequently on the news. So if you have interest, please visit her website. And she's also associate department head. And this is Professor Haiyan Wang. Her group does a lot of this, oxides, thin films, electronic materials device. And they also do a lot of in situ indentation in the TM. So this is some of the work they've been doing in the past. And she has a big group. And then they also send their students to national laboratories to do collaboration. This is our faculty, Chelsea Davis. She is our polymer faculty, expert on polymer mechanical behavior. A lot of cool studies on tripology, and then mechanical testings. And she has a really diversified and dynamic group of students. Now, I think this is one of the fracture tests of their polymer. Pretty cool video. Let me see. Well, this is a little bit on our research in the metal category. We do a lot of sputtering deposition, coatings, additive manufacturing of metals, and also ceramic sintering using spark plasma sintering. So this is our faculty, Ali Stratton. His group does a lot of modeling, primarily molecular dynamic simulation on the polymers, metals, as well as ceramics. And he's also, I think, the NanoHub's co-director, I think.
And if I can jump in,
Please, yeah.
It's a secret, but we'll let the cat out of the bag. NanoHub was just named a winner of an R&D 100 award. So the official announcement will be coming out this week, but we're very excited about that.
Great, yeah. So, and you'll probably be able to see Professor Strachan today, and at least himself and some of his students will be here. All right, so now this is another glance at one of the facility we have. This is the Composite Virtual Factory Hub led by our Professor Byron Pipes. Right here, he is a National Academy of Engineering member, and they have this big federal funded center with all sorts of additive manufacturing equipment. They're fabricating something pretty big for aerospace application. And then this is slightly outdated, and this is a table, so I will skip the table. But if you have interest, send us an email, and so we can send you some of this information afterwards. So this is Facebook. I mentioned our metallurgist, Mike Titus, or NSF Early Career Award winner. He needs a bunch of metallurgy students. Maria, she's helping to organize this Zoom event. She works on nuclear materials, and Macron, where modelings of heat transfers for 3D printings. You need some student right away. Dave Johnson, mechanics behavior material fellow, and Kevin Trumbull, big name on the aluminum alloy steel. And with department head, Dave is an expert on mechanical behavior, lots of nanonotation, nanomechanical testing, micropillars. And this is our structural materials where we do metals as well as ceramics. Raw Tries, he does a lot of ceramics, big programs, collaboration with Air Force Research Laboratory. And Wayne Chen, he's our joint faculty, but he's also associate dean. He does a lot of shock loading, high strength deformation. Electronic material wise, I've briefly introduced Professor Wang Carol. She does a lot of lead-free solders, very well-known expert, former group leader at NIST, National Institute of Standard Technology. Sriram Ramanathan does a lot of oxides, radio frequency sputtering, RF sputter. Ernesto Marinero, Edwin Garcia, modeling of battery electronic material. We're joined faculty, courtesy faculty Mike Manfra from physics, working on MBEs, and Rahimi working on soft bioelectronic material. He's our relatively new faculty and been with us for a couple of years. Chelsea Davis, soft materials chemistry, Miko Kakmak and Jeff Youngblood. And I think you're going to see many of them today. You can check out the itinerary. Kendra work on the polymer rheologies. Davian works on these energetic materials. And Carlos working on the microfluid channel device. Yanners works on a lot of these Olympic sports materials and things like that. So, and ceramic wise, we have also a variety of faculty. I want to point out Ken Sanage. He works on many DOE funded projects, and they have giant facilities and CNC machines to make ceramic big parts for industries as well as for government. And Raw Tries do a lot of additive manufacturing of ceramic materials, boron carbide, super hard materials, all this stuff. Modeling wise, we cover molecular dynamics, Ali Strachan, phase field simulation, Edwin Garcia, continuum level heat transfer, certification, and then DFT. This is administered calculation by Pei-Ling. Pei-Ling Liao, Professor Andrew Azab works on dislocation dynamics simulation, phase field, as well as molecular dynamics simulation. Our new faculty, Arun Kumar, he works on machine learning, artificial intelligence. So let me exit this and get back here. And this is a chart to show we cover a variety of land skills in modeling category. And we also have a courtesy appointment faculty. They recruit a lot of students from material science department frequently, from industrial engineering, Chandy, Barry, Mike Sanjeev, Vilas, Paul, and then we have, Luna and, Alex just recruited another student from us, he's a chemistry faculty. And of course, all sorts of news you can check. You can also check us on the Facebook. So that is a very brief update on the department. Let's see if the students have any question. Does any student have any question for us, for Dave? Specific or generic, either way.
Yeah, and we did. I should also mention that we just had new faculty join us this fall. Professor Nick Chawla came from Arizona State, where he brings the Center for 4D Materials Science. So we're getting a new CT system that's being installed next week, I think.
Next week.
For doing a lot of high resolution materials characterization and reliability of both structural and polymeric, metal and polymer materials for kind of microstructure evolution. So that'll be a new addition. So I think one of the things you'll see is that the department's relatively, like I said, it's dynamic. So we add, people change, projects come in. Yeah, our professional master's program, that just began this year. We had a plan, then COVID-19 hit, and so our plan kind of started slow, but we'll be picking up again next year. So one of the things you noticed on Professor Zhang's slides, the number of students that were getting masters have been dropping, and we know that there's interest from people doing coursework-based masters. And we talked to many of our undergrads choose to go to other schools and do that, and we didn't have that option. So the professional master's is really tied into coursework based with a little bit of a research project that's usually an industrial tie-in. The professional master's is a program that does not provide financial support, but it's designed to be done within a year, and it allows courses in both engineering as well as some courses in management and business a little bit. So it's really tailored for somebody who knows they want a job in industry and often in a role that's a introductory management type position. So that's something that we want to continue to grow because we know there's an interest from students, or we've been told by our students that there's an interest in that, and we want to respond in a reasonable way for that. So we've just begun that program, and we're looking forward to having students join us coming forward. And we would expect most of the students in that program to finish in about a year. So it's targeted, but it's a little bit up to each individual student. We also have an online master's program through Purdue Engineering, where you can get a concentration in materials. So the Master's of Science in Master's of Science of Engineering from Purdue Online, you can get the engineering degree broadly with a concentration. That's a 10 course that's designed to be done primarily by working professionals. So that's a program where students are taking maybe 1 or 2 classes a semester, and the 10 course master's sequence may stretch out over 2.5 years, 3 years or so. And we every year probably have about 6 or 7 students going that, but the official degree is a Master of Science in Engineering, and the materials is a concentration, which is kind of like a minor for grad school. Is there a strong collaboration between Chemi and MSc? There's some interaction. There's, both. So Professor Villas Pol, who was listed on there, is in chemical engineering. The other tie that's very strong is Professor Rakesh Agarwal. Rakesh is an expert in lead-free and earth-abundant material solar cell, and he and Professor Handwerker have been co-advising students probably 10 years. So that's a pretty strong tie. So in terms of the soft materials, there's definitely some interaction, but I think we have a large number of faculty doing soft materials, and you should recognize about half of our students come in with materials degrees, and about half come in with degrees from outside. So we have students whose undergrads were in chemi, in chemistry, in physics, in mechanical. So it's a pretty broad stretch of where our undergrads come from, where people did their undergrad and then choose to go into PhD for materials. And I should mention Professor Wilker and Professor Way. Those Professor Wilker works on adhesives, and Professor Way works on a wide variety of chemical processing, and is currently advising PhDs and MSc.
Yeah, and I think, so Dave, there are students asking about additive manufacturing. I think, basically, we do have, very active additive manufacturing program in terms of metals. So we have a additive manufacturing of metal 3D printer. We just installed a machine about half a year ago in my group, and we basically are printing 316 stainless steel nickel alloys. We were talking about it this morning. Probably will change to some other materials later this week. We also have Department additive manufacturing of ceramic programs. This is Professor Raul Trice. His group does a lot of those ceramic additive manufacturing. He collaborated with Jeff Youngblood. Professor Jeff Youngblood, he's a polymer guy, and they're doing a lot of, I think, polymer composites. They have to tweak the viscosity, things like that, in order to make it to work. So there's a lot of cool stuff in additive of ceramics as well as metals.
Right, and then Professor Sandage is doing binder jet for titanium-based systems. And that's a different technology than the laser-based. We also, and then as Professor Zhang mentioned, Trice and Youngblood basically are doing FDM on ceramics that are sintered, but they have a sol gel ceramic composite system that goes down as a gel, and then they turn into a ceramic with very little shrinkage. And then in the composites chopped fiber area, Pipes and Monson are working on a tremendous number of large-scale additive programs. They've done a project with Ford for making tooling. So I think they've taken a really neat approach of using additive to form tools for composites processing. One of the big problems with making a machine for stamping composites out of a polymer, stamping a polymer-based composite, and your tool is made out of metal, you have a different thermal expansion coefficient. As you heat it up and cool it down, you end up with parts that can warp. So if you can do a carbon fiber tool for your stamping of high volume parts like trunk hoods or trunk lids for a car, you then have the ability to get a really designed, a part with very little residual stress and uniform properties. And so that's, I think, a really neat approach where they're doing additive for tool making for the composites industry using tools. So I think you'll see the approach with additive here on campus is that there's it's somewhat decentralized. It's not like we have one spot, one building for additive manufacturing. We have a lot of different, people are looking at fundamental research as well as how do you then do something like Professor Sanjid, who then goes up and does microstructure evolution and characterization into argon beamline of Inconel 718 parts that are additive manufactured. Okay.
So Dave, the question now is, what do you think is most unique about the MSc program?
So
exciting.
What's the most unique or exciting about it? So I'm really I think the thing that gets me excited right now about the graduate program and materials here is this idea that we are pervasive, and that when I use the phrase, we have no normal, that really is becoming, it's truer every week. So our students are not, so the most unique thing is that we don't have a unique thing. So we are well positioned for people to work on challenging problems that require relatively large groups. So as an example, the hypersonic material, materials that are going to operate at extremely high temperatures, often for a very demanding application. There's going to be high vibration, there's going to be high temperature. That is not a one-person kind of project. And so what I think is really the most exciting about what we're doing right now is that we have an environment that lets people have some projects of their own, but then we have enough people around that you can put together the group in materials to make a new material. The folks in Aero can be testing. So Professor Sandage can have a new high temperature material for a rocket nozzle that's taken over to Aero and Mechanical Engineering and tested in a rocket fixture stand so they can look at erosion over time on the rocket nozzle of how that impacts the thrust that comes out of the part. So that's kind of that mix of we're small enough to know what everybody's doing, but we have the resources of the entire university around to be able to find those neat things where, oh yeah, you can run a project from, from raw materials to finished project tested. And you're probably collaborating with people in multiple departments. The sensors that are being put, people are working on sensors for patch type biological sensors. So Professor Stanshu and Professor Rahimi, they work with people in electrical engineering for how they're going to do the signals wirelessly back to a main component, how they're going to be able to process and use this with a low power use so that it's not a large battery attached to something, or how it makes a color change, and then you need to be able to identify the color change optically. And so they'll collaborate with the folks in electrical and with the folks in biomedical engineering. So that range of things you can work on here, I think, is where the most exciting parts is. And yeah, there are several groups that do biomaterials, and I think we got, and this is my, we got both kinds, soft and hard. So there are people that work on things that are implantable. So Stanshu has done things over the years with resorbable ceramics for implants. And then there are people that are more on the tissue and soft material side, like Professor Rahimi integrating electronics into that, as well as somebody like Professor Davis, who looks at the mechanics of stretchable things. So if you want to make skin, your skin is not going to have a fixed stiffness. It's going to have to be able to change. So there's quite a few people that are tied in. And biomaterials is a really broad category. We do have, we should point out that our alumni have a strong record of working within Indiana has a big biomaterials and medical materials community. So ranging from Lilly, we have alumni that work down at Lilly doing pharmaceutical and drug discovery, up to the Depew and Stryker crew up in Warsaw that makes Warsaw's in northern Indiana. Half the hip implants in the country are made in Warsaw, Indiana. Little Indiana trivia you may not have known there.
And I encourage all the students to please leave your email contact information. Very briefly, your name, email, and what is your interest in which direction, so that way we can follow up with you. Yeah. And after this, we'll move to the materials Zoom link. So if you have question, how do we get this, and you can send an email to me or Kathy. And basically, let me share this one more time. You can, have, depend on your schedule, but we have pretty much covered the entire 10 to 6 time window. Let me go here. This is the schedule for today. So that way, make sure you're covered, right? So faculty-wise and also the student. So we have at least 2 breakdown rooms to make sure faculty and students can talk together. All right, let me stop sharing this. So do we have any other question from the students?
Yeah, so our students that are on assistantships, the standard package in MSE, anyone that's on a research assistantship, and everybody begins 100% on research assistantships. All PhD students end up doing one semester where they TA, though that may or may not stay depending on how many people we continue to grow and how many classes we have. But the benefits package, I think, you should be looking at grad school. It's enough to live on. There's health insurance tied in, and both with the fellowships and with the assistantships program. The grad school website has a bunch of information on that, and it does vary a little bit every year, just like every job out there. So each year the insurance package is updated. A couple of years ago they added dental to everybody. So things get added, things get subtracted over time. And I think if you talk to our current grad students, you'll find that when we do exit surveys, everybody has said they're very comfortable with the stipend right now. It works for living here, and it lets them do what they need to do. So, okay. So I hope you join us and tune into some of the information, some of the specific Zoom projects from the department. So the bit.ly/MSE-Expo. So hope to see you around this afternoon, and we will be in touch, and I don't think we can hang out here after 10:45. So
we'll move to a different room.
So and Rosemary and Kathy are some of the folks you may want to ask a little bit about specific things on insurance and such. Okay. Anyways, it's been nice talking with